guys stalking me? That's so creepy. Never do that. This is why you have no friends. But anyway, you guys can come along with me. Whoa, check that out. Come here, quick. This thing right here, this plant, is a very rare species. It's called a tree. Okay, a tree. So, in 2020, these things will die out from pollution. So, think about next time you drive, when you start driving, think about how many trees you're gonna kill. So. Oh, what's this? A treasure of the jungle? Look at this, it's an iPhone 9D. Whoa, these are expensive. And what's this? It's open to a news page. So, it talks about how Donald Duck is firing missiles at Syria, 113 missiles, but misfired right at the United States.
Oh, so you have seen it too. You have seen that Donald Duck has fired 113 missiles at Syria. It has misfired and is going for northern Massachusetts.
Well, so what's the probability of getting hit by one of these missiles within a 1 mile radius?
Alright, well, if you do the math here, right, you'll see that you have 113 missiles, and the square mileage of northern Massachusetts is 5,283 square miles. And if you 113 divided by 5,283, you get 2.14% chance of being within 1 square mile of hit.
So, the chance of getting hit by a missile, is that impossible practically?
Pretty much, but there is more to probability than just dividing the number by the number of outcomes that are possible. But let's say, for example, you drive every day through the intersection at Coolidge and Main. Even though it may seem that the light never turns green when you're there, so you show up and it's always red, you know this can't really be true. In fact, if you really think hard, you can probably remember a time where you just flew straight through the light. So what's random here? Light itself is governed by a timer. Its pattern isn't haphazard. In fact, the light may even be red precisely at the same time every day. It's the pattern of your driving that is random. No, we're not saying you're a terrible driver and you can't keep your car on the road. At the precision level of 30 seconds or so, the light is spent to be red or green. The time you arrive at the light is random. Even if you try to leave your house at exactly the same time every day, whenever the light is red or green as you reach the intersection is a random phenomenon. Say you get this data when driving by the traffic light. We'll denote the sample space S for the traffic, light S, equals open bracket, red, green, yellow, close bracket. In general, each occasion upon which we observe a random phenomenon is called a trial. At each trial, we note the value of the random phenomenon and call this the trial's outcome. When we combine outcomes like that, the resulting combination is an event. We sometimes talk about the collection of possible outcomes. We call that event a sample space. But your random phenomena always behave well enough for this to make sense. Perhaps the relative frequency of an event can bounce back and forth between two values forever, never settling on just one number. Fortunately, the principle called the law of large numbers says that as the number of independent trials increases, the long-run relative frequency of repeated events gets closer and closer to a single value.
Yeah! So, it sounds really complicated because I'm that, but what about two variables?
Actually, it's pretty simple. So, I know you got the probability of getting hit by a missile by trying to do some trials. Disjoint or manually exclusive events have no outcomes in common. The addition rule states, for two disjoint events, A and B, the probability that one of the other occurs in the sum of the probabilities of two events is the the probability of A union B equals the probability of B plus the probability of A. Chipmunk! The probability of A and B are disjoint.
Chipmunk for dinner today.
And for two independent events A and B, the probability of both A and B occurring is the product of the probabilities of the two events. A and B are independent, denoted by probability of A intersection B equals the probability of A times the probability of B, provided that A and B are independent. We add the probabilities of two events and then subtract out the probability of their intersection. This approach gives us the general addition rule, which does not require disjoint events. The probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B.
I'm gonna get out my trusty weapon with my loyal calculator. Stupid twig. Okay, so since this is one variable, we can use the random integer generator, or randint, that is located in El Calculator. So as we can see here, we can use 1 as the missile will hit, and 2 to 50, which is the missile will miss. So here's El Worke in El Calculator, and yeah, and I'll magically show an Excel sheet with all this work. So 3 missiles out of 150 trials hit us. So that's about like
0.02.
mental math. 0.02 or 2%, which is still a very, very low chance. So I don't think it's gonna hit us. Idiot.
Yeah, but there's still a chance of getting hit. I'm just gonna go back home, which is totally not that tree over there. And just remember, you can't conclude that the probability of something without doing some trials, because sometimes it may turn out to become a very different value.
Fine, leave me, okay? I'm gonna look for some flying penguins anyways.